Hi everyone, this video is on exercise 12b from pure 1, question 3. So we have the point A with coordinates -2, -8, which lies on the curve with the equation y is equal to x cubed. And at point A, the curve has gradient g. So in part A, we want to show that g is equal to the limit of 12 minus 6h plus h squared as h tends to 0. Okay, so whenever you have a question which is about gradient and then you also see showing some limits, then the first thing that you should start thinking of is differentiation from first principles. And in this case, we first need to begin by writing basically the formula for differentiation from first principles. So we always I've actually written that here, so it's just that f dash x is equal to the limit of f of x plus h minus f of x over h as h tends to 0. So that's the formula. And then we need to understand, once we have the formula, let me write that down because it's probably better to have the formula now. So you have the limit, and then here is h and f of x plus h minus f of x. Okay, so this is the formula when you want to differentiate using differentiation from first principles. And we need to understand what to substitute all the time. So it's actually very simple because you just need to look at the function, and it depends on the question, because sometimes, like the previous question, which we had just the function x squared, and we wanted to show that the derivative is equal to this limit. So in that case, you just substitute the function and you keep going with just x. Whereas in this question, we have the function as well as a point. And in this case, we need to substitute both the function and the x coordinate of the point into the formula. And in this case, we are going to write the same thing. So here the limit, and then as h tends to 0. Then for f of x plus h, what we do, we need to understand that in the usual way, when we don't have a point, we just say x plus h cubed, because that's, the function. But since now we know that the x coordinate is -2, so we do -2 plus h, -2 plus h, and then we are going to substitute in the next step. So f of -2 plus h, so we first just substitute, and then minus f of, again, instead of writing f of x, we write f of -2, because -2 is the x coordinate. And now in the next step, we can substitute into the function. So now we have, instead of writing f of -2 plus h, we can simply write -2 plus h cubed, because again, f of x is x cubed, so we substitute -2 plus h into the function, which is x cubed. And this is, then it's minus f of -2, which is -2 cubed. Okay, so at this point, we just need to expand the bracket and simplify that. Then we can find a limit. So it's going to be -8, then plus h cubed. Then we have two more terms. So one of the terms is 3 times the first term is squared times the second term, then plus or actually minus, because it changes. So the next term is -3 times the first term. So I use the minus for 3, so here I just wrote 2, and then times the second term is squared, which is h squared. And finally, I'm just expanding, so I'm using the Pascal's triangle without actually writing that down, so you can expand this whichever way you like. So, and then finally we have -2 cubed. So -2 cubed is -8, but then it's minus, so it's going to be +8 at the end. So now we have the limit of, so we get minus 8 plus h cubed, and then here is 4 times 3 is 12, 12h. Then here is minus 6h squared plus h, sorry, plus 8. Okay, at this point, we can't, so minus 8 and 8 cancel out. That's good. Other than that, we can just divide everything by h. So this cancels out the denominator, this h, this power, and then here becomes h squared. Okay, we finally have the limit of h squared plus 12 minus 6h. And that's exactly what we wanted to show, right? Because that's 12 minus 6h plus h squared. Okay. So that's part A. Now part B is just basically finding the value of g and just solving this limit. So for part B, we need to see what's the limiting behavior of this function and just basically see what happens as the value of h tends to 0, just gets extremely small. So we need to always write this down. So as h tends to 0, then we can say what happens to what is the function. So here the function is h plus 12 minus 6h tends to. So you can always use this format. So say as this limit happens, then this happens to the function. So it's just about showing what's going on. Because if you just write down the value, you might lose a mark. Okay, so as h tends to 0, basically the term h squared just becomes 0. I mean, because it becomes extremely small, so it kind of loses its effect. And then 12 doesn't change because h doesn't affect 12, and then minus 6h also gets very, very small and close to 0. So it basically tends to 12. Therefore, the value of g, or the gradient, actually is 12. And a good trick is always just because for those of you know how to differentiate this with the usual way, you can always differentiate the function very quickly and then just check that your answer from first principles is correct. Because not all the time, like this question, they give you what's the answer. They just say differentiate this using first principles. All right, that's it for this video, and thank you for watching.